Alkenes are reactive, and the way they react is by undergoing addition reactions. For an addition reaction to occur, you have to have a CC double bond. Within that double bond there's a weak pi bond, and that breaks and a small molecule is added across the double bond, or where it originally was. So a double bond is there in the alkene, and then the product is no longer there and something's been added on in its place. That's why it's called addition. So two molecules will become one, they add together. Originally the alkene was unsaturated, afterwards it becomes a saturated molecule because there'll be no carbon to carbon double bond anymore. So we'll look at some examples. Hydrogenation. So small molecule we're adding on is hydrogen across the double bond. We need nickel as a catalyst, and the conditions need to be 150 degrees centigrade. So here we've got propene, that turns into propane. So a hydrogen has been added onto each carbon which is in the double bond. And this is how margarine is made when we take plant oils, which are very long chains, and we hydrogenate them. So we make them go from double bonds to single bonds by adding hydrogen across those double bonds in an addition reaction, and we make margarine. We could, instead of adding hydrogen, add a halogen, so it would be Cl2, Br2, I2, and again it adds across the double bond, so each carbon in a double bond gains one of the halogens. Okay? This particular reaction is a test for unsaturation, so the test for a carbon to carbon double bond. And if you do this reaction, the bromine water starts off orange. Because there's no bromine water in the product, because it's added onto the molecule, it will go colourless. So the test is to go, bromine water goes from orange to colourless. Okay. Now we could add a halogen, a hydrogen halide like HBr, HCl, HI. Okay, so one of the carbons will gain the hydrogen, and the other one, in this case, will gain the Br. But it could be, it doesn't necessarily one go to one and one to the other. It could be either. So in this case, the first carbon's got the hydrogen, and the second carbon's got the Br. But in this case, it's the other way around. The bromine's gone to this carbon, and the hydrogen's to that one. So this one will be 2 bromo propane, this one's 1 bromo propane. So 2 possible products, because this is not a symmetrical alkene. If it was symmetrical, if it was ethene, it wouldn't make any difference. There'd be just one product. Okay, but this one's not symmetrical. And we could also do addition of steam to make an alcohol. So the water, one hydrogen will go to one carbon, and the OH of the water will go to another carbon. So here, the first carbon's got an extra hydrogen now, and this carbon's got an OH. But again, because it's not symmetrical, it could go the other way around. So here, this carbon's got an OH, and this carbon's got an H. Okay, so here we've got propan 2-ol, and here we've got propan 1-ol. So 2 possible products again.